and welcome to the AWS APAC Webinar Week. So my name is Markku, I'm a technology evangelist, and let's take a look at scaling your applications. So how do we get to scale? What is scale here? We are really talking about millions of users, so it has some interesting, unique challenges. Well, if you start Googling scaling on AWS, you will get a lot of results. In this example, we had more than 1 million results, and many of them start pointing to something called autoscaling. Well, you have a lot of things to read, and that's not exactly where you want to start. Autoscaling is a really good destination and tool to help you, but there's a lot we can and should do in the meantime. So what do we need first? Let's take a look at some basics. What we actually need to do is to start from day one. You don't start with millions of users. You start with one user, yourself. And you start developing your application from scratch. And where do you actually start from? Well, if you want to use AWS, let's take a brief look at what is AWS and where is AWS. Well, first of all, this is the global world map showing where we have data center presence. This is slightly outdated because we keep iterating so quickly. Ohio is already online. Anyway, we have 14 AWS regions currently, and a region in AWS is a geographical location where we have clusters of data centers. Never just one data center, because that would be a single point of failure from facilities point of view. We have clusters of them that are interconnected by low latency network in the same geographical region. So here in Asia, we have regions in Singapore, Beijing, Seoul, Tokyo, and Sydney, Australia, and in Mumbai in India as well. And out of these geographical regions or data center clusters, we then provide our services. Today we have over 70 services. We have the widest and deepest portfolio of cloud services that we have been building over the last 10 years that we have been in production now. Well, we could spend a lot of time on this particular slide, but just to summarize, on the very bottom of the slide, the green bits there are the physical presence. We have the data center regions like Sydney. We have multiple availability zones or data centers within the same region. And in addition to that, we have points of presence. So if we have 14 regions currently, we have many more, around 55 points of presence around the world, where we deliver our content delivery network and DNS services. They help you accelerate your content delivery to your customers. Now, out of this physical infrastructure, the regions and availability zones, we then provide our services. AWS primarily provides IT infrastructure and platform level services, so not really the software. We do have a marketplace on top of the stack where we have our customers and partners who are delivering their software appliances as software as a service in the marketplace where you can discover them. But the primary value of AWS is to provide infrastructure and platform services for you to build your solutions and run your applications in the cloud and store your data and analyze it, etc. So when we look at the blue layer there, the core services, out of the infrastructure, we provide the fundamental core services of computing, storage, and networking. Pretty much everything in IT needs compute, storage, and networking. We have different flavors of that. We have virtual servers, we have Docker containers, we have serverless computing. We have object store, we have block storage, we have databases for various ways of storing and analyzing your data. We have a sophisticated security layer that makes it easy for anybody to achieve even higher levels of security than you could do by building it all by yourself. And then on top of these infrastructure and security layer, we have the platform services. So just to summarize, what is a platform service? It provides more value, a higher order of service. With infrastructure, like deploying servers, you need to manage the software and operating system yourself. So you make the decisions what packages to install, you install the software, you configure it. When you use a platform level service like big data analytics, Hadoop clusters with Elastic MapReduce, you don't need to know how to install Hadoop. You just want to run a Hadoop cluster. With a couple of mouse clicks, a few minutes later you're running a Hadoop cluster with the tools that you need. So the point of a platform level service is that it provides more value, more automation, and you just enjoy using the service for the higher order activity. Anyway, the point of the AWS platform is to provide you with a portfolio of services that you should consider as Lego building blocks. You pick and choose the services that you need, like maybe compute, maybe content delivery networking, maybe user authentication, encryption, maybe machine learning and data warehousing. And then you should focus your activities on building your application. So focus your effort on your secret sauce, which is your code, your software features. So let's get back to the beginning. Day one, user one. You start developing your solution. What could it look like? Well, to begin with, you should of course cost optimize your system. And the cheapest way to run a development system or any kind of system in AWS is to run one server. You can actually run one server for free for a year, enjoying our free tier with a new AWS account, running a micro instance. That's perfectly fine for you to develop and your software and to do unit testing, for example. You don't need more capacity than that. So this could be your development and initial testing environment. One easy to instance or Elastic Compute Cloud virtual server running an operating system of your choice, maybe Windows, maybe some Linux distribution. So on this server then you will install your development and maybe testing environment. Because you have only one server, you have the full stack on this one server. You've got your web server and web application, maybe your database and your management software and systems. One server. Then you may want to use an Elastic IP. With an Elastic IP, you basically book a particular public IP that is reserved for you. You can move it between servers if you have multiple, and the point is that you always know what is the IP address of your server. You can shut down your server, bring it up with another new dynamic IP, and that's your same familiar Elastic IP back to this server. Because nobody wants to really remember IP addresses, you could also use Amazon Route 53, which is our DNS service. Why? So that you could create a nice host name like development or dev.mydomain.com. You can provision your domains either with Route 53 or somewhere else, and then you can manage your domains with Route 53. Managing domains means that you can add nice host names like development system and testing system and maybe production system. So one server, maybe Elastic IP, and a nice host name for you to connect to, all running on AWS. At some point, maybe when you populate your database more, you're running heavier testing, you may need a bigger box, if you will. So you start with the micro instance, but maybe at some point you need more CPU, more memory, or more disk size or performance than that micro instance gives you. Then you can do vertical scaling. You can replace your server with a bigger box, if you will. The cloud makes this easy. You can shut down your original instance, say the micro instance. You can choose a larger instance size with more hardware dimension in the dimension you need, for example, more CPU or more memory or more I/O or all of those, and boot up the server with this bigger hardware, virtual hardware, if you will. You stop paying for the original server because EC2 makes you bills you by the hour, and you continue paying then a slightly different fee for your different size next instance type. This is the simplest approach for you to change your server size. However, because you're doing vertical scaling, you're replacing your server with a different size server, eventually you will hit an endpoint. When you have the biggest server available in the platform, that's it. You have scaled up as far as you can. So it only takes you so far. We have some other issues here with our day one system as well. This is great for software development and maybe unit testing, but it's not great for production. Why? Because it's fully non-redundant. You have one of everything here. There's no failover of anything, no redundancy. All your eggs are in one basket, that one particular instance or server. So let's start now scaling our system a little bit. The most common way to start splitting performance and splitting load on your system is to separate your database away from your front end and application servers. The databases are quite heavy. They usually take a lot of memory, disk, CPU, etc. And if the database is hogging all the resources of your server, there's nothing or not enough left for your web and application server. So it's a good idea to separate your database instance away from your front end. Also, this helps security because then you can do more layered security. Your web servers would be internet-facing and your database would be perhaps in an internal network with no direct internet access. So there's many benefits for separating the database away from your application server. Now, when you want to run your database separately from your front ends, you then have the next question in mind. How do I run my database? You can always run any software, including database software, by yourself on Amazon EC2. So basically you would deploy another virtual server with EC2 and install, the database engine of your choice in that EC2 instance. For example, MySQL, MariaDB, Oracle, whatever. You would install it there following the installation procedures of that database software. But then you have to remember that you need to manage it. You are the DBA. You need to do everything. You need to make your database hopefully scalable, secure, reliable. You need to remember to do things like patching, maybe backups, restore, mirroring, replicating, etc. All this sounds very complicated, and it is. I've been doing production database management and technical support in my previous career, and it's not easy. It's one of the heaviest tasks you can do. And if there's any problem with the database in your system, that's typically a big problem. So what is an alternative? An alternative to managing your database yourself is not managing your database, automating that task. We have a service called Amazon RDS, Relational Database Service. It's created exactly for this particular reason. You don't need to manage the database yourself. The time and effort you normally take for managing your database, you can use on more productive tasks, your solution development, serving your customers. So with Amazon RDS, you can automate the database, and automate it means that RDS service will take care of the operational aspects of patching it, securing it, scaling it, giving you things like replication, backups, mirroring, etc. easily in an automated manner. You can choose the engine. Currently we have Amazon Aurora, Microsoft SQL, SQL Server, Oracle, MySQL, MariaDB, and PostgreSQL. All of these as a fully automated database engine. In addition to that, we have Amazon DynamoDB, which is a managed NoSQL database service. More about that later. And then we have Amazon Redshift, which is a massively parallel petabyte scale data warehouse service. So it's not an operational transactional database for running your applications. Amazon Redshift is a data warehouse for business intelligence analytics. So we will not talk more about this now because it's not a database you would use for production systems for serving your customers. Redshift is for analytics. So I gave you two options there for the managed databases, SQL or NoSQL. What should you do? Well, we actually recommend that you would start by using an SQL database. Why? Because everybody knows SQL databases. It's a really established and well-known technology. There's a lot of competence, there's a lot of materials, existing best practices on that, a lot of existing code, communities, etc. And you can easily scale to your first 10 million users with an SQL database, following some best practices that I will show you today. Why would you then consider a NoSQL database, for example, DynamoDB? NoSQL is great for quite extreme use cases at very large scale. For example, very, very low latency applications where your database needs to reply within single-digit milliseconds, not to delay customer transactions at any scale. Or maybe metadata-driven data sets, highly non-relational data. Maybe you need a schema-less data construct, which is not strictly defined that you can modify your database tables in runtime by adding some items there that you didn't originally have. Very large amounts of data, because NoSQL databases scale horizontally. And then very, very fast access, maybe thousands or tens of thousands or hundreds of thousands of requests, reads or writes per second to a certain database table. NoSQL is better there. If you really need to have a NoSQL database system, in the AWS cloud you can consider our DynamoDB service. Why would you do that? Well, first of all, it's zero management. It's literally zero management. You don't install DynamoDB, you don't manage it at all. You literally just create your tables, create the indexes, and start using it. And then with DynamoDB, you can simply specify the performance that you need from your database tables. You can monitor what is the actual usage, like how many reads and writes per second you are hitting to your tables, and then you can simply issue a modification request, and online, DynamoDB will then scale your database table to that new performance level. It provides unlimited storage capacity and unlimited throughput, and single-digit millisecond response time, so it's consistently fast. DynamoDB is durable on SSD drives, so it's non-volatile memory, unlike an in-memory database. So DynamoDB is great for very, very quickly, rapidly accessed tables, consistently fast. Let's get back to our diagram here, our architecture. Now we have more than 100 users, so what does that mean? You've done some development, you've done some unit testing. Unit testing means that you have functionally tested that your system works. Maybe you start some small-scale performance testing now, or maybe you open up your MVP or beta application to friendly users. So you have maybe a few hundred users testing your system before you go into full production. Now you need this database separately. Let's say that we use Amazon RDS to make our life easier and fully manage our database for us. Then we have an EC2 instance running our web and application server, and customers or friendly users in this case are accessing our system through Amazon Route 53 with a friendly host name like www.myapp.com. That is then pointing to the Elastic IP and sending the customer requests to our web server. And our web server is then calling or using the database backend with Amazon RDS automation. Now, to add redundancy to the system and to add more capacity, we should leverage multiple availability zones in AWS. So I mentioned earlier that AZs are clusters of data centers that are fault isolation zones. They are interconnected by low latency networking. And by leveraging multiple availability zones, you can split your entire system across multiple data centers. Your entire system means that your entire stack, everything you do, all the data tier, the application tier, the web tier, all the networking, etc., should be running in multiple availability zones in multiple data centers. Then you can withstand not only losses or failures in individual components, but even the unlikely scenarios that we have facilities level incidents, we still have multiple other availability zones and data centers running. So you can still access your data and your application is still running and serving your customers. How would you do this? Well, you can, for example, add a second web server. And instead of creating the second web server in the same data center, you would create it in another availability zone in the same region. Then by default it goes to another data center. Now you have two web servers. And note here that you don't want to create the second web server manually. When you do things manually, we are just humans, so we make mistakes. So you need to start using certain levels of automation. So a quick and easy way to have an identical web server, the second web server, is to simply make an image of the first one. It's a couple of mouse clicks in our EC2 console. You make an Amazon Machine image of the first web server, and you boot the second web server from that image. Then both of them are identical. Then when you have more than one web server, to use both of them, you need a load balancer. So your customers would not anymore connect directly to that one web server. Now your customers will connect to a load balancing service. Instead of creating a load balancer yourself and managing it, which is again undifferentiated heavy lifting, you should consider using our Elastic Load Balancing service, which makes your life easy. You just create a load balancer, and then your customers will connect to that load balancer endpoint. You will configure your load balancer to know what your servers are, that you have the server pool. Currently you have 2 servers in your server pool. The load balancer will health check your servers, and if your servers are responding healthily, then the load balancer will start balancing customer traffic to those 2 servers in this case. If either one of those servers is taken down or fails for any reason, the load balancer will detect this failure and balance all the customers to the remaining server or servers. And then when you fix your broken server, the health checks will start working again, and Elastic Load Balancer will bring that fixed server back to the active server pool. So this is how you can start then scaling the number of web servers. And you have also redundancy because you're running your web servers across multiple data centers in the same region. What about your data, your backend data? Well, with SQL servers, SQL database servers, there is always one master. This one master handles all the writes. That's just how SQL servers work. So with Amazon RDS, you can automate and managing this server. But how do you get redundancy? RDS has a nice feature called multi-AZ. All you need to do is simply have a couple of mouse clicks and specify, yes, I would like to have multi-AZ database, please. When you enable this, RDS service will automatically create a synchronous replica of your master, a copy of your master database server in another data center. And synchronous replication means that any write that goes to the master database, the primary master, all those IOs, all those writes are replicated and copied on the secondary backup server. And synchronous replication means that the backup will need to acknowledge the write before the master will tell the application that the write is complete. So we have guarantees that both of the database servers are identical for all the data changes. In case of the master failing for any hardware software reason, the system and RDS service will automatically detect this failure and your applications will fail over to the secondary server, which will be promoted to new master, and RDS will automatically start creating a second replica to always have two synchronized replicas of your database. This would be really difficult to create by hand, and that's why RDS has the feature to automate all this for you. You can just enjoy the fact that your database is now replicated across two data centers. So I mentioned Elastic Load Balance earlier. It's a really easy to use service to balance to any number of requests from any number of customers and balance your customer transactions to your server pool in the backend. So now you know how to scale vertically by replacing your servers with bigger instances and by scaling horizontally by adding more servers. So now your system can look something like this. Your users are still connecting through Route 53 domain name resolution. Now your website like www.mydomain.com is pointing actually to the load balancer endpoint. So your customers connect to the load balancer and their traffic is balanced across a pool of servers running across multiple availability zones. The M here in the blue database backend here is the master. All the writes go to the master. The S on the other side is the synchronous backup of the master that we discussed earlier. And then you can have Rs as well. You can have read replicas. So Amazon RDS also supports scaling out the read performance of your database backend by creating asynchronous read replicas. Asynchronous read replicas are database copies, database servers that are asynchronously replicating all the changes from the master. Asynchronous means that the master doesn't have to wait for those replicas to acknowledge back. Because at some point, waiting for the acknowledgement from a very large number of servers will actually start slowing down the master. So read replicas don't slow down the master because the master doesn't have to wait for them. So in this case, if you have read replicas, your applications can be configured to point to the read replicas for the read requests, and only the write requests will then go to the master. This lets you scale even more your database backend. And again, these are automated features of Amazon RDS, so it's very simple to enable this with a couple of mouse clicks and a few minutes of automated action for you. Now all this takes us pretty far, but we care about performance and efficiency. So let's improve things a little bit more. What we can do is shift some load around. So currently, all the content from your application, all of it is stored in your database server and served to your customers from your web server for every single click, every single request that your customers make. What we could do is first to move our static content from the web servers and database servers to Amazon S3. Why? Because static content doesn't change. Static content are images, videos, etc. Things that you regularly send to your customers but are not dynamically created. There's no point loading the database server and web server with static content. It's much better to move them to Amazon S3. Why? Because Amazon S3 is a great place to store any number of files. It has unlimited storage capacity. You will never fill Amazon S3. It's extremely cost efficient because of our economies of scale and pricing model, and it's highly durable. We have 11 nines of durability in Amazon S3. So if you store, for example, 1 million files in S3, theoretically in 100,000 years you could lose one. That's 11 nines of durability. But for web server or any kind of applications, S3 is the best place to store your files, and then you can serve them to your customers directly from S3 without any servers, without any web servers. And to accelerate this content delivery to your customers like images and videos even more, you can add content delivery network in front. You could serve all your content like images and videos directly from S3. S3 scales horizontally. But especially when you have a global application with customers potentially in different continents, your customers will enjoy a better user experience if you use a content delivery network. By using a CDN, you can actually deliver your content locally or nearby to your customers. So instead of serving or sending your data directly from S3, maybe from Singapore to North America or South America, when you activate Amazon CloudFront distributions, you can enjoy our currently 55 edge locations around the world, many, many more places than where we have data centers. And you can cache and store all your content in these edge locations near to your customers. Then instead of downloading from Singapore or US East, for example, your customers may download the content from Hong Kong or Taipei, etc. This gives them lower latency, higher throughput, and smaller packet loss. Your customers will enjoy a better experience, and interestingly, when you activate CloudFront or CDN, you have a significant reduction in the number of customer requests that hit your backend system. Because generally, CDNs or content delivery network caching takes care of about 90% or so of your customers' requests. They are served out of the cache. And maybe around 10% or so go to your backend system. So you can actually survive with a much smaller backend system by activating content delivery network on the edge. Your customers are happier, they get much faster experience. You are happier because you pay less. Your backend system is smaller and you can scale your system far bigger. So now we've done this. The static content requests are going from Amazon Route 53 to CloudFront content delivery network, and then ultimately served out of Amazon S3. So S3 is then filling the cache in the edge of the network in CloudFront. And only the dynamic requests, so content that you create dynamically per user, per request, based on who they are and where they are on your website, only the dynamic requests are hitting a load balancer, your web server farm, and then your database in the backend. And to accelerate this dynamic part of your site even more, you can consider moving your session state management away from your web servers. What is a session state? For example, a shopping cart. If you have an online shop, HTTP is sessionless. People are clicking around, but from systems point of view, those are individual transactions. But your customers actually have a session. They put an item in their shopping cart, they click around more. You should remember that they put this item in the shopping cart. Where do you remember this session state? Somewhere else, not on the web servers. Why? Because your load balancer, to have maximum efficiency, your load balancer should be able to balance any customers, any transaction to any server. Where is the shopping cart information? Somewhere else. Your web server will store and update and fetch this shopping cart or session state information from this other service. For example, DynamoDB. So if you keep your session state or shopping cart in DynamoDB, it replies back to your web servers within single-digit milliseconds every time at any scale. Your web server doesn't have to remember the shopping cart, which means that you can send your custom request to any one of the web servers in your farm. That's also better for reliability. If one of your web servers fails, it doesn't matter. You don't lose session information or shopping carts from any customer because they are not stored on the front-end web servers. They are stored in DynamoDB, which is durable. So your web servers can simply serve individual requests, and they don't have to remember any customer sessions. You keep the sessions in DynamoDB or in Elasticache, which is another commonly used option. Elasticache lets you run in-memory caching with Memcached or Redis. So very similarly to DynamoDB, it replies very, very quickly to any requests for storing and fetching this session state information with single-digit milliseconds or even faster. The difference is that DynamoDB is a NoSQL database service storing the data durable on SSD drives. Elastic Cache is an in-memory database cache. Both of them are easy, both of them automate managing this cluster on your behalf. It's more of a philosophical question, which one do you prefer to use? So now we get to a much larger scale already. But now we can actually revisit the beginning of our talk, autoscaling. So we are already running multiple web servers, but until now we have deployed them by hand, if you will, from the same server images. We can automate this task with autoscaling. So what is autoscaling? Autoscaling is quite simple actually. It lets you detect high load in your system and automatically add more capacity where you need it. For example, if your web server fleet is getting highly loaded, you can monitor this with, for example, the CPU load or I/O, etc., different operating system metrics or incoming network traffic to your system. You can choose which metrics show that your system is getting loaded, your servers are getting loaded, and then you can have an action, an automated action. You can specify, for example, that if my web servers are over 80% CPU load for 3 minutes, have an action, like add 2 more web servers or 1 more web server to the fleet. And vice versa, to save money at night time, when your system is cooling down, you have another metric, another action. If your web servers are below 30% utilization for more than 5 minutes, remove 1 server from the server pool. But never go below 2. Never go below 2. Don't go back to a single point of failure. So always keep at least 2 of everything running, just in case. How does autoscaling help? Well, if we look at a large website like Amazon.com, a typical weekly traffic looks like this. You have peak times in typically afternoon and evening, and at night time there's very little traffic. If you provision static capacity, most of the time you have too much capacity. It's even worse in real life because there are some days where you have peaks for whatever reason. So to serve those peaks, which are much higher than your average customer load, you're wasting a lot of capacity. In this case, 76% of your provisioned static number of servers capacity would be wasted, and you're actively using only 24% of the server capacity. So provisioning for the maximum ceiling, maximum load consistently in a static manner is not a good idea. Autoscaling lets you do this. With autoscaling, you simply raise the roof and constantly add capacity when needed to any scale, and then release the capacity and save money when you don't need this large capacity anymore. Autoscaling lets you do that very easily. So now we are at this kind of situation here. Let's recap a little bit. Your users use our Route 53 DNS service, and all the requests are pointing at our edge network, CloudFront CDN distribution. CloudFront is sending the dynamic requests to Elastic Load Balancing Service, which is in turn then monitoring and load balancing the customer traffic to a server pool. The number of servers is not fixed. Autoscaling is adding more servers to multiple availability zones and then removing unnecessary servers when your load is low. And then your database backend, you have a master in one availability zone, you have a synchronous replica in another one, and you may have read replicas for SQL read request scale out as well. Your session state for your customers and shopping carts, whatever, can be in either Elastic Cache or DynamoDB, not in your web server, so web servers can be stateless. And then your static content is served out of Amazon S3 like images and videos. And everything is accelerated by CloudFront CDN distribution. And you have caching in multiple layers. Elastic Cache and DynamoDB act as session cache, and CloudFront is caching all of the requests, both the static and dynamic ones. However, one does not simply deploy that kind of a system by hand. So you should use automation. There's many tools, open source and commercial tools, to help you automate your systems, and the AWS platform provides many of them, and they are free to use on AWS. You don't pay anything for the management systems that give you automation. You simply pay for the resources that they deploy, like servers and storage. So what are some of the options? Well, this graph or diagram is trying to show you that you can balance between maximum control, where you choose everything, and maximum convenience, which automates even more on your behalf, and you can focus on other tasks. Maximum control means that you do everything by hand, you deploy EC2 instances, you install the software, maybe even database, and you manage them by yourself. You could use tools like Puppet, Chef, and Ansible to do operating system package management, etc., but you're still managing servers. AWS CloudFormation gives your deployment automation. It uses templating systems where you can basically create cooking recipes that describe your entire system on AWS. You get a template file, which is basically a JSON document, and then you can deploy this template, and AWS CloudFormation service will reliably, repeatably, automatically build your system from this template. You can iterate on this template, you can change it, like change your domain name for your Route 53, etc. Maybe change your database options and apply your changes, and CloudFormation will automatically then detect the changes in your system template and automate your running system management. So with CloudFormation you get template-based automation. Another option is to use AWS AppsWorks, which gives you a graphical user interface on the web console, and you can build from stacks these layers of your application, like the layer for application server, you choose to use Nginx, for example. It's a slightly different take on how you manage and automate your system. And on the extreme automation end of the scale, we have AWS Elastic Beanstalk. Elastic Beanstalk is the most automated, most opinionated system where it does certain default choices for everything. You can still configure some things, but the main thing of Beanstalk is that it automates almost everything for the infrastructure for you, and you can focus simply on application development. So let's take a quick look at Elastic Beanstalk. What does it actually look like to use Elastic Beanstalk to deploy a web service into development, testing, or production? Let's now switch to the AWS console. We are here. I've already logged in to my account. This is the AWS console where you can see our different services. Now to use Elastic Beanstalk, we find it under Compute. We click on Beanstalk and we go to the Beanstalk console. I'm using the Singapore region in this case. Now here we are in Elastic Beanstalk. I'm not running any application in Singapore with Elastic Beanstalk, so the first thing we could do is to select what type of application we want to deploy. The idea with Beanstalk is that it gives you an environment to run your app. So in most cases, the environment to run your app means that it builds the infrastructure for you to run your code. So you have to choose which language you want to use. If you're coding Node.js, you want Beanstalk to build an environment to run your Node.js app. Same for Python. Or you can use Docker, for example. So with Docker, you can have any kind of binaries, configurations, any language you choose. And Beanstalk can then help you automate your Docker-based application deployment. What does it mean that Beanstalk will automate it for you? Beanstalk will then build and manage and operate the infrastructure like servers and storage and even the database and load balancer and auto-scaling on your behalf. You don't need to do any of those. You simply upload your application, Beanstalk builds the environment and runs it for you. You can do things like upgrade, downgrade, etc. and modify certain configurations. So let's show you how it looks like. Let's just simply choose that we want to run a Node.js application. So let's launch an environment. So we choose that we want to start coding in Node.js, and we ask Beanstalk to create an environment for us. So I don't have to now go to EC2 and deploy a server. I don't have to figure out how to run Node.js on EC2, on Linux or Windows. I don't need to install any storage. I don't need to provision buckets in Amazon S3 Simple Storage Service. I don't even need to deploy databases, even with Amazon RDS. I don't need to go to Elastic Load Balancing, create a load balancer, and then make an auto-scaling group. All of these things including CloudWatch monitoring, etc., are automatically created and managed and operated and monitored by Elastic Beanstalk. It's simply creating the entire infrastructure for you now, and in a few minutes, once this is done, we won't wait for that, but it will take a few minutes. Once it's done, you have an infrastructure ready to run your Node.js application. You can simply focus on coding it, making a new version, and pushing a new version into production with Beanstalk. So that's the maximum convenience and level of automation, if you will. Let's get back to our slides. I mentioned CloudWatch monitoring. What you need to do in production is to monitor everything. If you're not monitoring, you're flying blind, then that's not good. You're going to fly into a wall. So AWS has a service called CloudWatch, and it gives you a lot of metrics on different parts of your system, the services you are using, the units of compute, storage, etc., and you can monitor what's going on. You can have host-level metrics on individual hosts, aggregate-level metrics on things like your server pools, and there's plenty of tools around the AWS infrastructure from open source communities and commercial tools that even complement further and give you different types of monitoring and logging and analysis tools. It doesn't matter what tools you use, but just remember you want to monitor end-to-end from your customers through their end-to-end traffic to your backend system and then up and down the stack, all the layers of the stack. If you don't have monitoring, you don't know what's going on. We can even improve the system more by doing some architectural decisions. You can run any kind of application on AWS in the cloud, but to have the most scalable, the best possible scalability, reliability, and durability, you should consider service-oriented architecture. AWS already is a set of services. All the things you use in AWS, like compute, storage, networking, analytics, databases, whatever, are as a service, delivered to you as a service. You simply use them, either using the web console or APIs. If you make your application also a set of services, then you have everything as a service. And it makes your life better, because you can scale it better, you can develop it better in small chunks, you can iterate things faster, and you have better security control, layer security, when you have individual components, not everything in one huge blob in one basket. You should avoid tightly coupled components. Tight coupling means that any software client that you have is asking something from another piece of software. Tight coupling means that you ask and you wait for the response. If the second guy or component is very busy, or for whatever reason, the first one is waiting for the second one, somebody else is waiting for the first client, and you end up in a deadlock situation. Everybody is waiting for everybody else. A recommendation is to do loose coupling. Loose coupling means that if you need to request some help from another piece of software component, you use message queues in between. Message queues buffer the messages or requests between the software components. The first component puts a request in the queue and it continues serving the next customer transaction. It doesn't wait. The component who is being asked for something clears the messages from the queue when it has time. Loose coupling is really one of the best ways to ensure high reliability and scalability of your system. It's a topic of its own. We have sessions on that, but just keep it in mind and study it more if you're interested in this. Now, to get to more than 1 million users and above, you need to now recap a little bit. We need to use multiple availability zones, spread our compute and storage and networking across multiple data centers. We have to use load balancing between tiers because we have multiple units of compute, not just one. Autoscaling makes this easy to determine how many units of compute we need. You should consider microservices or service-oriented architecture to split your application into multiple components, scale them out horizontally, and have no single point of failure there. Serve your content smartly, cache wherever you can, add caching to all the different layers. Serve static content out of Amazon S3 and CloudFront, not from your dynamic web servers with compute. So now it can look something like this. You have your web server farm with auto-scaling. You've got your database with replicas and mirroring. You have your session state either in DynamoDB or Elasticache. You may use simple queue service or other queue services between your software components with microservices architecture. You have CloudWatch monitoring to make sure that you have full visibility into your system. You have Amazon S3 serving static content and CloudFront accelerating everything. What are the next big steps then? Well, at some point your SQL database may run into problems with scale. So you have some options of even further scaling your backend database with SQL. One of them is database federation, basically meaning that you don't have just a database. You can have multiple databases, each of them with Amazon RDS. So multiple database masters for different types of database. Your forums database, your users database, your products database, etc. That's one way of doing it. Then you have, again, more capacity and scale. If you need to scale a particular table or database beyond what a single master can do, you can consider sharding. Some people say that you shouldn't do sharding because it's too complex, but many people do sharding. That means that you split your database into multiple instances. So you have, for example, a third of your users in shard A, a third of your customers in shard B, and the remaining in shard C. Then you need to know which particular database shard you should contact. Some people use, for example, hashing algorithms, hashing from the customer ID, the destination that it should use this particular database server. So you have an additional layer of, if you will, management and architecture for figuring out which database to use when you do sharding. If you need to do resharding, adding another shard, that can be another complexity of its own. But so this is again a topic for its own webinar, but if you need to go beyond what one table can handle in one database server, you can consider sharding. But actually, an easier way could be just to use DynamoDB. If your table that you need to scale beyond what a single database server can do, if your table is something that you could serve out of a NoSQL system, so more simple access method to that, so no complicated multi-table joins or something, you could use NoSQL. So with DynamoDB, your tables can have any size and any throughput. So you don't hit a limit at any point. You don't hit a limit. It's unlimited scale for your tables. So many people move their hot tables from SQL servers to DynamoDB for this reason. Let's have a quick review. Use multiple availability zones, never have single points of failure, all your eggs in one basket. Make use of self-healing and self-scaling services, or automated services like Elastic Load Balancing, Amazon S3, simple queue service, etc., where you don't have to manage their scalability, redundancy, etc. We do it on your behalf automatically. Build in redundancy at every single level. Identify any single points of failure and get rid of those, following our best practices. Use caching anywhere you can. Caching always helps in all the layers of your stack. And automate everything. Don't do things by hand more than once. It's not a good thing. Automation gives you reliability, repeatability, speed, etc. and just makes your life easier. Make sure that you have good metrics monitoring end-to-end and up and down the whole stack, otherwise you're flying blind. Try to break your application into multiple components that do one thing only, like this is my billing system, it generates the customer bill. This is my web frontend, it generates the web or mobile frontend, for example. Only one thing, and then you scale that component horizontally by adding more instances, EC2 instances, or maybe AWS Lambda serverless computing, just for that component, and you scale it horizontally. In front of that, you may have a load balancer then. Use auto-scaling for determining automatically the number of servers you need for each one of those microservices or tiers. Don't reinvent the wheel. Don't manage and install databases, for example, by hand, because there are automated services that do it much better and makes your life easier. And you should really focus your effort on creating new software features, fixing the critical bugs, and listening to your customers and serving them better. Automated services make your life easier and release your time for these more meaningful activities. Now when we put all of these together, we should now easily be able to handle 10 million or more users, basically to infinity and beyond. Now that was this particular session. I really hope that you enjoyed it.